Swayam Prabha. Digital India. Educated India.
Welcome to the semester-long course on Energy Resources, Economics and Environment. My name is Rangan Banerjee, and today we will start with looking at the basics of the energy flow diagram. So let's start with an energy flow diagram. What is an energy flow diagram? When we think in terms of any human activity needs energy. So if you are looking at the screen that you see, the screen has to be illuminated. If you are looking at the comfort conditions, when we think in terms of air conditioning or the cooling, and that also needs energy. So that energy comes through a whole sequence of steps. We have the energy that is available in nature is primary energy. This is the energy sources like coal, oil, solar, natural gas, wind. The energy that is available in nature is not directly something that we can use. We take that energy, we convert it in an energy conversion facility. So we first take the coal, convert it, we mine it, we wash it, we transfer it to a power plant, and then we get the secondary energy. So secondary energy is the electricity that we get from the power plant, which is burning coal. That secondary energy itself goes through a whole network, a transmission and distribution system, and then it reaches your house or it reaches the campus, the final energy that we buy from the distribution company, and that is then used, that electricity then goes and it is used in your air conditioners, in the fans, in the lights to give you useful energy or the end use activities. So whenever we think in terms of different energy systems, we need to look at all these terms: primary energy, secondary energy, final energy, useful energy. We are interested in the energy services. In order to provide those energy services, we need to have primary energy extracted. That primary energy needs to be converted in a conversion facility to give secondary energy. That secondary energy is distributed till it reaches the final end user, and that's the energy that we buy, the electricity, the oil, the natural gas that is used in the equipment to give the useful energy. So when you talk about each of these conversion steps, each conversion step needs a certain amount of energy for the conversion. And so if you need 1 unit of energy, useful energy, we would probably need 2 units or 3 units of primary energy. So whenever we do a comparison and when we do a calculation, we can think about whether we are talking of primary energy, secondary energy, final energy or useful energy. So let's move on. When we talk about all the end users that we need, so we think of all the things that you do in your daily life. When we look at cooking, the energy service is the food cooked. So you have the chula or you have the stove or the microwave oven. That is where energy is being used to give you the processed food. If you talk of lighting, the energy service is illumination. You have different kinds of bulbs. You have the traditional incandescent bulbs. Then we've had the fluorescent, then you have this compact fluorescent, and now you have the LED. When we talk about transport, we are looking at traveling, distance traveling, so passengers being transported or goods being transported, and then you have a whole host of cycle, car, train, motorcycle, bus, aircraft, and each one of them is an energy system and has a conversion and an efficiency. In the factories, we have a large number of motors which are being used to create some shaft work, and the device is the motors. Cooling, we are looking at space cooling. We have fans, ceiling fans, and we have air conditioners, we have refrigerators. In the industrial processes, we have heating that is provided, that is fluid is being heated. So, the devices are boilers or geysers, and in each of these cases we can look at what is the energy input, what is the output, what is the energy service, and do this kind of analysis. So, just to give you an example, let us look at a situation where we are using an agricultural pump. A farmer is using a pump to pump water. The pump output is the useful energy, the useful service, energy service that is required. The pump is providing the energy in from the motor drives the pump, and the pump is transferring the energy into the water, which is then allowing it to go to the storage or to the field directly. Each of these has a certain efficiency. The farmer buys electricity from the distribution company. That electricity is coming through a transmission and distribution system. That electricity is being generated in a power plant which is using coal. That coal is being mined and transported, and then you have primary energy. So, if you look at typical efficiencies of all of this, the numbers that we have put, the mining efficiency may be of the order of 90%, power plant has an efficiency of about 30%, transmission and distribution about 78% efficiency, and the motor pump, depending on actual operating, may be of the order, motor may be of the order of 70%, pump of the order of 60%. The best efficiencies may be 88%, 75%. So, if you multiply all of this, you will see that the overall efficiency that we get from the coal to the final pumping, that efficiency is actually relatively low, and that gives us an incentive to try and see, can we reduce some of these steps. So, whenever we look at different kinds of energy systems, it is always useful to try and look at it, draw the energy flow diagram and look at it from the context of primary energy to the final energy service. So, let us look at what are the terms that we have studied. We have studied the terms primary energy, secondary energy, final energy or the delivered energy, useful energy, energy service, and then we can also classify it into different kinds of end uses. So, end uses will be like one end use is lighting, end use of heating, end use of cooling, end use of cooking, end use of transport, and then the sector. When we talk about sector, we are talking of residential, industrial, commercial. Whenever we talk in terms of we want to get an idea of an energy system, we have to decide what is the level of aggregation and disaggregation. What is aggregation and disaggregation? When I put things together, that is aggregation. When I separate them out, that is disaggregation. So, we may want to calculate for the city of Mumbai what is the overall energy use, or for the state of Maharashtra what is the overall energy use, for the country, for India what is the overall energy use, for the world what is the overall. So, that is an aggregate calculation. We want to disaggregate it by in each household, by each end use, how much is the energy use. So, that is a disaggregated. So, in any of these cases, we can always calculate and do an energy balance and try to see how the energy is being used and what is the quantification. When we move forward with this, in order to do these quantifications, we have different kinds of units. And so, traditionally we used to use calorie and the British thermal unit and the quad. Now, in the SI system, we use joules and we use kilowatt hours. We also need to differentiate between energy and power. When we are talking of power, if we are talking of watt or kilowatt or megawatt, that is the rate at which the energy is being supplied, and that power aggregated over a period of time will give you the energy. So, watt and horsepower, these are units of power. When you take 1 watt and you run it for an hour, you get 1 watt hour, or a kilowatt hour is 1 kilowatt running continuously for an hour. So, we need to be able to convert between different units, and for this you can look at any source on the web, or you can look at the energy basics in the global energy assessment, which I will put at the end of the references. We also have different prefixes like kilo 10 raised to 3, mega 10 raised to 6, giga 10 raised to 9, tera 10 raised to 12, peta 10 raised to 15, exa 10 raised to 18, and depending on the kind of calculation we are doing. So, if you are doing the calculation for the world, you will be talking in terms of exajoules. If you are talking of a country, maybe exajoules or petajoules. If you are looking at a smaller thing, it may be kilojoules or megajoules or gigajoules. There is also, these are all in terms of energy units. Earlier we could also calculate in physical units. So, we can talk in terms of million tons of coal, million tons of oil. So, there is an energy unit where all, if you talk of coal, oil, natural gas, we convert them all into equivalent oil. So, million tons of oil equivalent, and you will see if you look at the BP site or you look at many of these sites, the energy balances are given in terms of MTOE, which is million tons of oil equivalent. The coal is also converted into oil equivalent, and million tons of coal equivalent, kilotons of coal equivalent. So, these you should be familiar with the units, and you should be able to make conversions between the units, and so in some of the tutorials that we provide, you will have some examples where you can do this. So, here is this exercise which will give you an order of magnitude of the different kinds of units, and the idea is that you see for different kinds of activities, I want you to think about it and insert in order of decreasing energy, with the highest energy being on top and then the lowest. So, the different items that we have put: energy use of an average US detached house, burning a candle, the world energy use annually, the Boeing 747 going from Tokyo to Frankfurt and back to Tokyo, 1 liter of gasoline or petrol, energy use of an Indian village typically of 500 people, New York City annual energy use, solar energy reaching the earth in an hour, a power plant of 700 megawatt annual electricity production, and the daily metabolism of an adult. So, take a minute and just put down your sequence, the highest energy to the lowest energy, and if you see, compare the sequence with the results that we have here. The world energy use annually is about 500 exajoules. Solar energy reaching the earth is in an hour is about 445 exajoules. So, that means we have a abundant solar energy, right. In 1 hour we have enough, which is equal to the amount which the world is using annually. New York City annual energy use 0.8 exajoules, power plant 15.5 petajoules, 747 Tokyo Frankfurt to 9 terajoules. The lowest is the burning the candle, daily metabolism of an adult is somewhere in between, and this just gives you a sense of the relative magnitudes of things. Okay, so you can look at this on this axis. This is from the global energy assessment. You can see this. This axis talks about different activities and in different units, and you have a scale which goes from 10 raised to 1 to 10 raised to 23, and you can see the in terms of the starting from joule to zeta joule and going up to exajoule, and you can see the relative magnitudes of some of this, and this gives you an idea of the relative magnitudes of the energy used. So, this is very similar to the exercise that we just now did.